So, as we begin with this lesson, we want to look at, before we get too far into things, deciding what's going on with our data sets and are they increasing or are they decreasing or none of the above, and deciding if something is going to be a linear function or not. So, if we look at this first set of data, we notice with our y coordinates as we are increasing, so are our data points. However, they're not just adding each time a consistent amount, so this would not be linear. As we investigate the next set, we see that these data points are actually decreasing, but then they start increasing and then they go back to decreasing. So this inconsistent nature of increasing and decreasing would cause us to say that this is neither. If we look at our next set, we are consistently adding 4 each time. So this would be an increasing and linear pattern. And then our last one, we are consistently decreasing by 5 each time. So a decreasing linear pattern. Now, why is this important to us? Well, today we're going to talk about looking at different data sets and polynomial models to figure out a data set that will best fit. You will definitely want your graphing calculator handy or a TI-84 calculate type app. Now, in this particular set of data, we are looking at different sunspots that appear on the surface of the sun, and they last a few days to a few weeks. And over the years, they've been tracking how many sunspots there have been since 1990. So if we fill out this table, we have our years since 1990 and the number of sunspots that were recorded each of those years. And we want to take a second to look at would this table best be represented with a linear function? What about an exponential function? Would that be our best model for the data? Well, what we can see is this data doesn't really look like it's linear, nor does it really look like it is exponential. Instead, what it looks like is quadratic, because we see that this data set is decreasing until it kind of gets to year 6, where it starts having a little turning point down there and it starts increasing again. So what we would say is that this is best going to be represented by a quadratic. And the reason, again, that it looks like it's going to be quadratic is because it is a parabola with a minimum value. And that's basically what's kind of happening to fit this data point so far. So what can happen then with this data is we can use our graphing calculators and the regression capabilities to be able to find a model that is going to best fit this data. So what we're going to do is we're going to go under our stat menu on our calculators, and we are going to edit so that we plug in into list 1 and list 2 these different data points that we have from our chart on this previous page. And once we put this data points into our chart, we can go back under the stat menu, scroll over to calculate, and we want to create a quadratic regression with these data points. And what this is going to do is it is going to come up with our coefficients A, B, and C for our quadratic. And what we'll see here is that if we do that quadratic function, we get 6.001 x squared minus 67.513x plus 204.983 with our y values. And what happens is if we then go under our y equals menu and actually plug that in, so 6.011 x squared minus 67.513 x, and then plus 204.983, we can scroll up to turn on our plot. So hit enter. And then this time we're going to zoom stat. So zoom option 9. And we see those data points as well as that line that we graphed, how it's fitting through with that data. Now, this graph has a couple different features. First and foremost, we have symmetry to it, right? It's symmetric. It opens upwards. And it has a minimum value. Now, we can even specifically calculate where that minimum value is at, also using our graphing calculator. So if we hit second trace, that's going to bring us to the calculate menu. This time we're looking for a minimum, so we can scroll over to the left a little ways, scroll over to the right a little ways to calculate this bound over here. And then last but not least, if we scroll to this minimum point, enter, 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 we see we have a minimum point at about 5.6, 15.4. Will be our minimum point location on that. Now, what this also tells us then for part 7 is when are they going to be in the minimum? Well, that's going to be year 5.6, aka about 1995 or 1996, depending on how we're looking at it, because that's 5.6 years after the start of our 1990. And if we look at the top of page 121, we see this question here. Do we think we can use this to determine the number of sunspots when it's going to equal 200? The answer is yes, because we can set this equal to 200 and actually solve then for these minimum values. So we have this that we could set equal to 200, and then essentially we're able to set this equal to 0 by subtracting over the 200. And what this would allow us to use is use the quadratic formula, since factoring is not an option right now, and actually solve, since we subtracted 200, using the quadratic formula for what years those sunspots would be occurring. Now, overall, do we really think that this quadratic is going to be the best fit for our data when it comes to the past and the future? Not really, because what's going to happen is if we go back to looking at this, our data is getting really, really large. If the more negative this would get the years prior or the years in the future is also going to get really, really positive. So we would have an extremely large number of sunspots if we kept this model. Now, what we're able to do then beyond that then is look at a little bit more data points, because what we notice here is if they start giving us beyond those first 10 years, they give us 5 extra years, what we notice is that our data kind of hits another turning point and comes back to be a little bit smaller than it was previously. So this time we notice that we have a second turning point with what we call a relative max. And some of these words are highlighted on page 121 as well, but we've talked a little bit about a relative min, so it's where we see a minimum on our graph, that turning point. We also have in this case now a relative maximum peak point, and those overall are what we call our turning points in our data. And if we add on to this data these extra couple of points, so if we go back under our list and edit, and we keep adding on 11, 12, 13, 14, and 15, we can add on this data to get a different type of read, in this case using a cubic graph, because a cubic, if we calculate the regression here, now we have those 2 turning points, so a cubic could be potentially a better fit for our graph given having 2 turning points. And again, we are able to then create this regression for our cubic to actually create that data. So if we go back under zoom stat so that we kind of see we no longer want this quadratic because we need that extra turning point with that. So let's answer these questions. Which type would be best now? Well, we would want to use a cubic. Why is that? We have two turning points, a max and a min. And again, now that we calculated using the regression, we have y equals negative 0.0605 x cubed plus 14.937 x squared minus 103.359x, and then plus 239.810. Officially ran out of room on that. Now this time, if we actually analyze some important features on our particular graph, okay, again, there are going to be some different things that we can use with this calculator to actually calculate these different features using the capabilities on our calculator. So we have x to the third plus 14.937 x squared, and then minus 103.359 plus 230 x, and then plus 239.810. And this time, if we look at that graph, again, see it fitting the data points, we notice a couple of things. Number one, we have a y-intercept at that 239.81 is going to be one of the features here. So y-intercept 239.81. And officially, we like to usually list that as a point. So we would have 0, that. We have relative maxes and relative mins on this graph. So again, your calculator can allow you to calculate these. So we have the relative min to the left here. So maybe we just choose like 4. We have if we go to the right bound, then here, and then that max, and then, or that piece in the middle, you have that calculated. We can also do the same thing with the maximum if we scroll over to do, again, a left bound, a right bound, and then that peak piece as well. We can also get our maximum for this graph, and we see 11.5106-ish as our max on that. So again, we're getting these different pieces. So minimum at 5, 20.8, our max at 11.4, 106.4. We have 1, 0 on here that, again, we can use. We can calculate here using option 2. And again, if we scroll down to that 0, get very, very close. And again, we like the left of this. We go down to the right of this, back to that 0. We see our 0 is at about 15.1 is our 0. Would be where we touch that. And our overall end behavior, as our x values are getting bigger, our graphs, our y's, are going towards negative infinity. As our x values were getting smaller, though, our y values were going off the graph towards positive infinity in that other direction. Now, do we overall think that this is going to be an accurate predictor for 25 years into the future? Not really, because if we notice on this graph, we're getting more and more and more negative. So we're not going to have a negative number of sunspots. And then same thing if we're trying to look into the past here and we're trying to figure out, okay, 200 BC, aka an x value of negative 2,190. Well, if I'm trying to calculate that value, right, at negative 2,190, looking into the past here, oops, that's just looking like a huge number that we are not going to want to calculate. Yeah, it's not even coming up as a valid answer, so that'd be pretty large to be able to get. So again, if we're actually going to come up with what would probably be best for this graph, it's actually looking like it probably is going to, in time, end up being a sine graph that goes back and forth, would probably be our best pattern on this one. Now, there are a couple on here for you to look at. For this first one, you are looking at this data and deciding what type of graph it is. Use your calculator to calculate the regression on it, and then try and analyze some of the key characteristics that you notice modeled by your function in that. All right, thanks everyone for watching. We will work way more with these and your calculators in class.